So if you are new to this, the format of the Nature Journal Educators Forum is that it is a kind of collective discussion between the best minds we can pull together on different nature journaling education topics. So whether you're a homeschool parent, whether you are a formal educator, whether you are an informal science educator, or wherever you might be, we're finding these discussions really useful for helping us collectively move closer towards best practices in nature journaling. And today, the three of us, Yvea, myself, and Susan, are going to each be sharing some things that we think are really, really fun and important strategies with numbers. And then we're going to have some time at the end to open it up for a discussion or for other ideas. Feel free also to use the chat function to comment and share ideas. To get us started, I wanted to just say a little thing about numbers. And I think it's how we think about them is really important, because for many of us, the joy of numbers was beaten out of us at a formative age. We were taught math solely as calculation. And it was a place where mistakes were glaring and in your face. And the sort of traditional schooling it emphasizes calculation and speed. So, you know, how fast can you solve this problem? How fast can you solve this problem? Think of that's basically the structure of most tests. You're doing speed math. There are many mathematicians who are not good at calculation. And so what's up with that? So mathematics is a language for describing the world and thinking about the world around you. And it is different than using words, and it's different than using pictures. Each one of these will take a different part of your brain and gets you to think about things in a different way. We're not saying that one is better than the other, but we're saying that they are each fundamentally different. And the way which we think about things will be different when we intentionally engage with numbers. And that is really significant. That is really important. So what we want to do is to give ourselves more tools for freely exploring and playing with numbers in our own nature journals. And so each one of us is going to share a number of things. And then we hope that this is going to be kind of a dialogue and kind of conversation, and then a whole kind of deep community geek out. There's Schrodinger's cat. It's alive. That's good. So as by way of introduction or sort of initial thoughts, Yvea and or Susan, do either of you have some thoughts? I'm back. That you wanted to share as sort of big picture introductory thoughts?
Yeah, I guess there's a few kind of, I guess, themes and things I've been kind of thinking about as things that I keep in mind when I'm working with numbers. So one of those I think is not being afraid to make mistakes or try things, not get things right. I'm a mathematician. The work that I do, like the research that I do, doesn't involve numbers at all. A lot of this is not necessarily any more immediately obvious to me than it is to anybody else, but it's fun to try things. And I've done a lot of things in my nature journal where I've tried to figure things out and things haven't worked out, but numbers are just giving me an extra tool to help me understand things in nature. And I think that's really the perspective that I want to have. And part of that is about being creative. People don't usually think about creativity and math, but if I could quote one of my favorite I guess scholars of the creative process. I found this quote I like very much. Creativity is your brain's ability to make useful connections between seemingly unrelated things. That's John Muir Laws. Which I was really delighted when I heard, because really creativity is not about doing art. It's not about drawing pictures. That's a component of it, but it's really about figuring out how to adapt the things that you know, the tools that you have, to new kinds of questions that you're playing with. And as I say, the tips and ideas and things that we're going to share are things that you can adapt when you are playing with a new phenomenon in nature. And you can think to yourself, this is one tool in your toolbox, many tools in your toolbox. How can I measure some things, count some things? What can I measure that might tell me more about this thing, or that might allow me to compare it to other things? So it's, you should have the perspective that these are tools that you can adapt and use as you want to, not necessarily something that you should be doing in a certain way because Susan told you that, or Jack told you that you should do it this way. So that's kind of the perspective that I would hold.
That is very helpful. So you're thinking of this as being playful.
Absolutely.
And having fun. It's not like you can be playful with the pictures, or write a poem, but when it comes to numbers, all of a sudden you have to be like, I like this. I like this. And if you've ever been to any of our solstice related kind of geek outs, or moon watching parties, you'll know that numbers can be really playful. Yvea, as far as kind of introductory thoughts, do you have anything that you'd like to share?
Absolutely. That I think of numbers on their own as, well, numbers on their own are for me a bit abstract. So it's important to have context with your numbers. I think is that we could just take numbers for the sake of taking down numbers, but I think it's important to consider why we're looking at that thing. For instance, if you're looking at cloud cover today and you're trying to estimate the approximate percentage of cloud cover, why are we doing that? Is it because we're trying to see if there's a storm coming? Or is it because we're wondering about how it's going to affect the plants that are growing in our gardens? Or is it because we want to see the effect it has on animals and which animals are more active with more cloud cover? So I think it's important to put context to numbers. I think that then it also helps us also to double check numbers and then to see if what we've measured makes sense. Because I think another thing that can be kind of scary about math is that I don't know if anybody else has had this experience back when they were in school, but being given instructions about how to do something, and then pretty much you're left with this idea that if you don't know how to, if you don't know how to use the compass correctly, then you can't really ask for help on that because the instruction should have been clear. But I think it's important to recognize, to build on what Susan said about making mistakes, to recognize where errors might be coming from. It paints a more interesting picture of your surroundings and your tools. It's important to be open about your process. So I think it's important to be able to make that a part of the process that students think about, and also that it can be a really informative process. So for example, instead of the student worrying because the needle on the compass keeps moving when they try to hold it out, then you can teach students to wonder, why does the needle not hold still? Is it because there might be some metal around? Is it because their hands shake a little bit? And then how could they steady their hands? Is it because of some other weird anomaly? So mistakes and trouble with tools can be really, really informative as well. And so I think it's important to be able to create a culture where students can question that more and to learn from it and to sit with that. So those are my big takeaways, is to look at the process behind the tools and also consider why you're taking the numbers down, to give it context.
That makes a lot of sense. So you're thinking, your big picture, when you are playing with numbers, you're thinking about what is the use of this, what does this show? Then you're looking at your numbers, asking, does this make sense? And sometimes, a reason for there may not be an overt reason for playing with numbers other than, let's see if a pattern emerges. right? Because that they're great at sort of simplifying systems and helping you kind of like, oh wow, there's a pattern to that. It's great. So maybe a good sort of next step would be for us, like, let's start thinking about, let's find numbers around us, right? So there are, if we want to start having more numbers in our journal, then what is just some low-hanging fruit about how to get numbers into your journal? What do you folks think?
Should we have people enter in some ideas into the chat of
Sure,
ways that they find?
that's a great idea. Everybody, let's drop that into the chat. How do you find numbers?
I can start reading out loud some of the answers. I'm seeing finding patterns. I'm seeing an acknowledgement that we were taught that there was no room for mistakes, and so hearing that it's okay to make mistakes into play is comforting. Date and time, numbers of birds, how many of each species, shapes, counting and duration, size, angles, quantities of leaves or petals, measurements, counting how many whorls of flowers on a plant, or counting petals or other things, dates, hearing a lot of good ideas here, distance, footsteps taken, days between. Yeah, please keep them coming.
Excellent, excellent. So I'm going to hold up a few tools that can, while this is going. Oh, temperatures.
I see comparing to my own height or hand or foot, biometrics. Repetition.
So I'm going to hold up a few tools for measuring things. So actually, maybe let's start with the idea of counting. So counting is really, really useful. So you constantly see old accounts of descriptions of abundance of wildlife. The air was filled with countless birds. Really useless statement. So when we can count things, we want to count them. And then Rebecca just added into the chat, if you can't count them, estimate them. And the ways of estimating things can be all over the map, right? So it can be, one way of estimating things is, there's 1, 2, 3, 4, 5, 6, 7, 8, 10, now 10, 20, 30, 40. So you can group count. Other ways of estimating, let's say the air you're looking at bat fly out, right? And there's all these bats leaving a cave, and you feel overwhelmed. One way of handling that might just be, I'm gonna at arm's length make a box, draw a little box of how big it is and hold it up at arm's length and lay on your back, and in 1 minute count how many bats go through your little box. Right, and then you just describe, this is what I did and this was the number that I got. This isn't any official bat metric, but it gives me a relative sense of the abundance of things. So it doesn't have to be a specific, the right way to measure bats.
If I can jump in and comment on that, what you're doing there is, at the end of that, you have no idea how many bats there actually are. But what you can do, if you've recorded what your process is the next night, you can do the same thing for the same amount of time. And now you can find out, at least estimate, are there more bats tonight than there were last night? Are there fewer? Are there twice as many? And you can get an idea. So even if you have no idea how many bats there are in the entire group the entire time, it gives you a slightly more objective way to compare one thing to the next. That's a really useful tool to have.
That's a huge point. So numbers, Rebecca mentioned patterns. So what Susan is suggesting is that if you get, so one number just says, hi, I'm a number, right? The minute we get sort of two numbers, we can start to compare those two numbers, and then you can sort of get more numbers to compare. You know, what is the start time of the bat fly out? What is the end time of the bat fly out? What is that like next week? What is that like the week after that? So when you are getting a series of observations, that's really, really helpful. And in some of the other videos we show techniques on kind of group counting and things like that. Yvea, maybe could you drop into the chat the link to the Forest Service counting systems? Also, I think David Allen Sibley on his website has some little things with dots to help people kind of practice counting. Estimating is something you can practice, you can get better at. The more, when you initially start, you're going to be terrible at kind of estimating numbers of things. You're going to look at, there's a bunch of ducks on the lake, and we look at that and we kind of go like, but I have no idea how many that is. Yes.
I'm so glad you brought that up. It makes me think of another thing, and that's this idea of counting in groups and math as a group activity. Something that Jack taught me before on different field trips was about something called the anchor effect, which is that if everybody's out there counting the birds, and you notice that sometimes in previous forums too, Jack has had us wait to press the button, the submit button in the chat all at once, so that way we're not being immediately swayed by the first answer that comes. And so, for example, if you're out there counting birds and you estimated 300, but then somebody else estimated 150 and they say it first, then you doubt yourself, and then you might be changing your estimate based off of their estimate. And so I think it's important to kind of balance the two, where you let yourself estimate independently without being swayed by other people's opinion, but then you also share this as a group, so that way you can look and see how we're getting to that number. And so for yourself, are you overestimating, and is that a pattern, or underestimating, is that a pattern? And then also as a group, what are the different strategies that we're using to do the counting? And then we pick each other's brains about what strategy this person uses. Is this strategy more effective? Does this one help me with the way that I think? So talking about strategies of how we get the numbers is super important, I think, because despite what we were taught maybe taught in math class, there's usually more than one way to get a number. It's not always necessarily just one method. And I think it's important to remind students of that as well, that there can be more than one way to get a result. And it's good to share that with each other. Plus, speaking of making mistakes, it's okay to say, if you see somebody's process written down, it's okay to say, right here, have you ever thought about doing this instead? It might be easier on you. Or this right here, have you accounted for this factor? And encourage that kind of dialogue with your students. So another thing to think about too.
What you're saying about that there's more than one way to get an answer makes me think of, I mean, this happens in science all the time. How old is the Earth? How old is a particular fossil? Which organisms are more related to each other and which ones are more distantly related? We have all kinds of different methods for measuring age of things, as an example, and they don't always give the same answer. And and sometimes the exact details of how you follow that method are going to affect what kind of answer you give and what kind of range of answers you get. And we're doing this all the time because all of our tools of science are not perfect. And the goal is to try and do these things, measure them with as much precision as we can, and try and investigate why they give different results, why they disagree when they do, and things like this. So, if you are estimating something and you're getting a different answer than your friend, you're just doing science. It's great.
That's really useful. So let's also think about some other ways of kind of getting numbers in there. Sometimes just having a tool, if you have a specific tool, if your students have a tool, if they've got something like this, they'll measure a lot of stuff, right? If they don't, then they won't. So other ways of handling that in the journals that I made, I put rulers into those journals. And so those are kind of built into the book. You can also just on the back of your own journal, put down a ruler and tick off centimeters. And now you've got a centimeter ruler in your journal. I also, on my website, I have downloads of pages that you can print out onto Avery labels that are rulers. So you can print out a set of rulers and give those to your students. And then everybody puts those stickers into the back of their journals, and then you've all got rulers. Any other thoughts on ruling? Which do you prefer, metric or imperial?
I don't care as long as we measure our angles and radians and not degrees. Sorry.
I strongly encourage people to use the metric system. It's weird getting used to it, but once you do, it starts to be really, really useful. So centimeters, millimeters, decimeters, meters, get used to those. And also, I want to encourage people to bring back the decimeter. It's about that big, and it's useful. It's exactly that big. And so some things, you know, if you're estimating the height of the back of a zebra, about how tall is that? If you were trying to estimate that in centimeters, good luck. But if you go all the way to meters, how many meters is the back of the zebra? That's not really useful either. So a good sort of intermediate measurement is the decimeter, 10 centimeters. And that also kind of keeps the continuity of, like, there are 10 millimeters in a centimeter. There are 10 centimeters in a decimeter. There are 10 decimeters in a meter. Bump, ba bump, ba bump, ba bump, chunk by chunk. So that ends up being a very, very useful unit of measurement for looking at sort of mid-size critters and things. So a good thing to get used to. How there was also biometrics was mentioned earlier. How big is your palm relative to 10? For me, this is about 10, about a decimeter across, right? So if I have my thumb out, and so, you know, that I can, you know, I can little palm my way along and get decimeters on things, and that's pretty cool.
Or take, for example, have you ever walked through a particular forest environment or some sort of natural environment and you thought, oh, the plants right here are about ankle height, but then you're wondering how far up is your ankle? If you're not carrying your fanny pack with you that happens to have, you know, all of your measuring tools with you, then it might be good to just know those biometrics about yourself so that later on when you say ankle height, then you know exactly what that is for yourself. Or you say, oh, well, this grass has risen to between shoulder and head height. And that can be a way, then you're noticing a range of grasses because the grasses all have different numbers in them. And if you don't have time to measure them, or if you don't have your measuring tool, then if you know this versus this, then at least it gives you approximations. And so sometimes that can be a good, just quick tool to have in your tool belt. So yet another plug for biometrics, plus it can be really fun. And best of all about biometrics, it's individual. So there's no right answer to that. Your kid, like the kids cannot look at their neighbors and be like, oh, that's the answer I should have gotten because it's their body. But then another thing to mention though is that kids grow, so you got to make sure that they take their biometrics a little bit more frequently than possibly us adults do, although I think we should also take them and double check for ourselves.
I'm now getting shorter.
Are you getting your haircut warmer?
Yeah, that's true. So also on that biometrics front, I don't have them written into this, but I have a little chart of I take out a big meter tape and I calculate how many steps it takes me to go 100 meters. And from that, I can figure out one step, how many meters I go. And then the other thing I want to go, in order to go, you know, 1 meter, how many steps do I take? So this little chart, filling that out for yourself, is a very, very useful thing. If there's an area you can find, either ideally with meters, but if not meters, then you can do this with feet, but figure out your pace. And so that is how, in one step, how many meters do I go? And in order to go 1 meter, how many steps do I go? That way I can say it took me 20 steps from here to here. How long is that? Or I can also turn that around the other way and say, how many steps would I take out this way if I walk 20 meters out?
Speaking of playing with numbers, here's a question for thought. Does the amount of your pace change based on what substrate you're walking on?
Absolutely. Sand, like little steps. And also it changes uphill versus downhill. So the you can practice it on a flat thing. You can also do it on a slope and walk up the slope and then walk down the slope and then walk up the slope and walk down the slope. You can get different numbers, but it's useful just to have kind of a ballpark sort of average for yourself. If you're looking for instructions on how to do that, I've got a Nature Journal Connection post on how to determine your pace. That's a useful thing, a useful biometric to have. And you have to write it down because you will forget it.
Something I wanted to flag in relation to the biometrics. I think so. The connecting our body measurements to actual numbers is very, very useful, and gives you some quick and dirty ways to measure things without even if you don't have your ruler or measuring stick or anything like that. So that's very handy. But I want to flag something that Aisha was saying in the chat and was asking about, is this question of basically, does it count if we're what about words as numbers, as big as small as, the largest, the smallest? I would absolutely count that under this category, even if you're not using any numbers at all. And in fact, as I said, at heart, the kind of math that I do is topology, and it doesn't do anything with numbers at all. And honestly, at the end of the day, it pleases me sometimes to be able to make these kinds of comparisons without assigning numbers to them, just to see how well I can do it. And just because that sometimes that gives me even a better sense of how big something is. So I go out looking for our Carter blue butterflies. They're as big as my thumbnail. Sometimes I find one that is a little smaller, it's as big as my index fingernail. They're a little smaller sometimes. I could measure that later on and see. Obviously, if you have bigger thumbnails, or if your thumbnails are longer, and I'll look at things and I'll say, oh, this leaf, the petiole, the word, is about as long as the leaf itself. That's interesting. I never measured either of those, but now I've noticed something about the proportions of those things, or that kind of thing. Or the tallest, the biggest leaf is at the top of the plant, the smallest leaf is at the bottom. And I'm doing that without even measuring. That's still telling you something useful, and it's still making sort of objective comparisons and measurements and things. So that's all of those things I think are really, I would fall into this category of using math in our, I know math is a scary word, but using math in our nature journals even before you pull out the ruler or use your biometrics to measure something. So I just want to highlight that is absolutely a valuable, useful thing to do and worth doing. And sometimes it's a lot faster than measuring something directly. So it means you get to go look at more things.
I love that thought, because any object that you find can be can be a unit of measurement. How many stuffed kadamas is my computer? That's one. That's two. My computer is about 2 of these. Right now, this is a non-standard unit of measurement, right? Because people go like, well, how long is the stuffed kadama? Well, that's why a centimeter is a useful thing, because we've all agreed on it's that length. But anything that you look at can be, when you're saying bigger than a cat or cat size, you're using the cat as your unit of measurement. And so, is it 2 cats? It's twice as big as a cat. Okay, so you're now using cat as your unit of measurement. Cat, cat, it's a double cat. It's two cat, right? And the so yeah, any object can be used as a unit of measurement. The disadvantage of that, again, is that because it's not standardized, what was the problem with the qubit, right? All right, I'm going to go measure that, and then somebody else says, all right, I want it exactly that size, and then somebody else takes their qubit and they do it. You're going to have your archway built a different size than the chariot, and somebody's going to end up in trouble. And so that's why these sort of standard units of measurement are useful. But as long as you document and describe whatever it is, I mean, or even like drawing a little picture of a beetle next to the beetle that you drew the enlargement of, and saying this was the actual size. That's great.
I noticed.
Yes.
Maybe after we finish this thought, I noticed that Aisha had an interesting thought in the chat about how she's been trying to call it math instead of numbers when working with students, and would like thoughts on that. So
I think that's more accurate. I think that's a lot more accurate. The thing that I like about words, pictures, and numbers is that kind of idea fits together, like words, pictures, numbers. Oh, okay, I see. The words, they're all like things you could put down on your page. But I think that the kind of the umbrella, thinking of as numbers as this whole sort of area of maths, is a lot more accurate. Let's take a look at another tool. This is a goniometer, and it's used by physiotherapists to help you figure out, like, you know, your inch to the shoulder. Whoa, hold on, I've now got smoothie all over my palette and desk here. Yeah, big puddle, big green puddle. Oh no. But this is the goniometer, and the goniometer measures angles. So you can measure angles on a branch. You can measure, you know, angles of, you know, when I'm looking at, you know, the what was it? So if I'm looking at, you know, the angle of a slope or anything like that, I can kind of hold this up. I can put it against whatever this is, and I can get angles with this. What's neat about having a goniometer is that if you have one, first of all, it's just a big ruler. That's nice. But it also, being able to measure angles, you'll find that you start measuring angles. Because if the only tool you have is a hammer, every problem looks like a nail. But if you've got a goniometer, then some of them look like nails, and some of them look like sort of angles that you want to figure out. So the goniometer has a protractor built into it, but you're not just the protractor you kind of hold up to somebody's shoulder and you kind of go like, oh, you're holding it about that angle. This, what they do is they say, like, oh, you can bend your knee this much, right? And then you can read it right off of this. And so it's giving you that 360-degree angle. So that's kind of a fun tool. It's sort of like the longer ruler. But and also this great tool for measuring angles. Another really fun tool is a compass that has an inclinometer built into it. If you look at this, see this red arrow right here? That always points down as I rotate it. So I can also use this to get slopes. I can also use this to get things like the height of the sun in the sky. If I just take this and the ones with the mirror on them, you can use the mirror to sort of see where that little measurement is. And on my website, I also have some tools on kind of how to use inclinometers. This allows you to get very, very accurately things like the height of the sun in the sky. So that's another useful tool. Can we think of any other kind of fun tools for helping us get numbers? Here's another tool to help you get numbers. Right. So if you have a variety of ways of getting numbers, the kinds of questions that students ask will be different. So tell us about that, Yvea.
So this was a little gift from Marley. It's measures humidity and temperature, which I think can be really, I don't really know a good way of estimating that yet, although I might come up with a way. So this can be just useful for trying to get numbers readings, although I'm kind of questioning if this one works properly or not. So that'll be something interesting to explore later. So yeah, I guess it's called a high-grow thermometer. Yeah, high-grow thermometer.
Nice. Does it also calculate relative humidity?
It just says humidity on it, so I'm not sure if it means relative or not.
Great.
I'm seeing an interesting question here from Mary Sturm in the chat about what about string for measurement?
So
Right,
yeah, Susan, tell us.
I'll say, well, just people, a lot of cultures have used string for measurement for thousands and thousands of years. This is a very classic tool for measurement. There's a lot of cultures that will do things. You either have a piece of string or rope and you could tie knots in it at certain evenly spaced intervals, say 1 decimeter apart. Now you've got a very handy, easily wound up tool for measuring decimeters. Make an extra big knot every meter or something, depending on how long you want your string to be. Or if you just happen to have a piece of string, you say, oh, I wonder, can I record how tall that bush is? Well, you could stretch your string out from the ground to the top, and you could tie a knot or make a mark with a marker or something like that, whatever. That you'd have that tool, and then you could come back the next day and say, oh, it's grown taller. Oh, I can compare because now it's taller than the mark on my string. Absolutely, why not? Yeah. You suddenly realize you don't have any of your tools with you, but you desperately need to measure that thing. You could pull your shoelaces off and measure them that way. Hopefully your shoes don't fall
off. What about some fun ways of when we get numbers, the way which we record them changes the way we think about them? What are some strategies for documenting numbers in our in our journals?
Well, I'm seeing Billy Joe mentioning graphs. Graphs can be fun to play with.
Should we bring Billy Joe in? Add you into the spotlight, Billy Joe. See if you've got enough bandwidth.
Yes. Yeah, I'm sorry, I'm at work. It's always a crapshoot on whether or not my internet's going to be good or not. I love graphs. Graphs make me super happy, and I think that you can do lots of fun things with them. And so one of the things that I did during COVID was I put my bird feeders right outside my window that I was working at, and then I was able to count for the birds that came to the bird feeder. Yeah, so I kind of counted over 2 days who came to the bird feeder, and then I put it into a double bar graph, which was super fun. And so I colored that, and then I was curious, and then I took a closer look at the beaks to see, like, because it's a mixed seed, so like what maybe all these birds were here, but they all have very different beaks. So were they eating the same seed or different seed or whatever it was? And it all started just with a simple tally marks, and then I sort of, migrated into that. So I think graphs are really fun and just ways to sort of clock with what you see out there and sort of being able to put it, and then being able to take that information and then like manipulate it into something else. And for little kids, they can manipulate it into like pictographs instead of, double bar graphs and things like that, or, sort of all these different things. And so that's where I think that taking the information and then seeing how you can manipulate it in a different way is kind of really fun. So hopefully that came through on my crazy internet.
Can I ask, what you said, a double bar graph? What were the two things that you were?
They were over the 2 days. So I did, one color was November 17th and one color was November 18th.
Oh, okay. And so you had just
So then I was,
number of birds of different species?
yeah, different species. So I had
Okay.
chickadees, nuthatches, goldfinch, junco, mourning doves, downy woodpecker, and then male and female cardinals. And so then I was able to see sort of, you know, what they were doing. Now, if I wanted to get even more nerdy, would be to then clock the times that I was doing that. And then I could have taken that, like now in hindsight, taken that a step further, which was then to clock, like I was watching the bird feeder from, you know, 12 to 12:15 p.m. And then another day was this time or whatever it was, or try to watch at the same time, because then now you can add in even more information in ways to manipulate those numbers, which is kind of fun.
Also, you know, how long since you last refilled the bird feeder, and what proportion of different kinds of seeds are in the bird feeder and who's eating them?
Yeah, exactly, right? So
This is the thing about numbers and graphs and things. They're addictive. Like once you start, you just keep going. You keep thinking of new things. Boy,
yeah,
it can be a problem.
kind of
Those are kind of problem.
infinite. And I think one of the really fun things, I was talking to students last week or whatever. Oh, we were doing biodiversity and we were sort of doing some nature journaling of like macroinvertebrate species. And I said to them, can we figure out the population of like how many of this one species is living in the pond? And they were like, no. And I was like, what are you talking about? I'm like, we could totally estimate it. I said, how many samples did we take out of the pond today? And we had 5 groups. We had 5 big samples that we had taken. So I said, couldn't we all count how many of each species was in those 5 samples? I said, multiply that and then, you know, do like an estimate on the perimeter of how big the pond was and potentially how deep it was. It's a vernal pond, so we know it's not super deep. And I said, couldn't we figure that out? And they were like, oh. And I was like, math is cool, right? And I said to them, like, when I was a kid, I didn't like math either, but like math is super cool when you can start to manipulate it in different ways that make it interesting, right? Like that to me was really interesting. And in terms of being able to like take that they saw, you know, a couple of predaceous diving beetles, and then, you know, these are things that they can do and take and manipulate those numbers, which is really fun.
That is really fun. They're just like,
Aisha is asking me to show my page again. So hold on, there you go.
say, you know, how many seeds does this bush produce in the season? Well, a lot, right? Right. But you know, but can we find out how many seeds per berry? Can we find out how many berries per cluster? Can we find out how many clusters per major branch and how many major branches per bush? Right.
And I think the other,
we then have error bars around that, but we can figure stuff out.
Yeah. And I love that it's like it's easy math, right? Like everyone, all the kids get nervous that it's like scary math, and but you're just adding, and then, you know, like when we multiply, we're just fast adding. And so just being able to like not give them these, you know, these huge formulas that you have to kind of dump all this information into. It's really just like step by step by step by step. And I love how you just said that. It's like, let's see what the berry has. And then let's see, you know, how many are in a cluster. Like we're just adding on to that one original idea, which I think like makes it less scary when you're talking about math, because everyone's like, math. And so at least that's how I always felt when I was a kid.
That's fun.
Sometimes as an adult too.
The
Susan.
thing I want to flag in relation to that is actually something I meant to mention earlier when Yvea was talking at the beginning. I forgot. But Jack, you said there are error bars on that. And that's a really, really important thing to note. Unless you have 5 apples in front of you and you can count them 1, 2, 3, 4, 5. If you are counting a large number of things, even if you think you counted them correctly, you're probably wrong because 2 of the animals probably moved. You know, if you are measuring things, you are definitely wrong. Whatever number of berries you estimate, or whatever number of seeds you estimate on that bush, is definitely not the right answer. Right? Error is a fundamental part of all of this stuff. It is so important that the entire field of statistics is actually about understanding error. That's what it is. Like, you cannot avoid it. So the thing is, if people are afraid of making mistakes, don't worry, because you're definitely going to make mistakes. The point is, in anything that we're measuring, we want to think about and understand, you know, all the ways that we are estimating. And when you're estimating, you're kind of compounding what that error is. So if you're doing this process, for example, of measuring, you know, how we're estimating how many seeds does this bush produce, well, you know, not every berry has exactly the same number of seeds, so there's some error there, right? And then not every cluster has exactly the same number of berries, so that could be more or less, right? Not every branch has the same number of clusters on it, you know. So you're getting this error, but at the end of the day, you'll be able to figure out probably an order of magnitude. You'd be able to say, oh, this bush produces 1,000 seeds or 10,000 seeds. It probably doesn't produce 100,000 seeds. That would be pretty good. That would be like getting that order of magnitude. That would be like pretty useful, because there's probably another bush out there that does produce 10,000 seeds or 1,000,000 seeds. Wouldn't that be interesting to find out? Wouldn't it be interesting to compare different kinds of flowers and how many, like, order of magnitude, how many seeds they've got, right? Even if all you can do is you can say that it's more than 10 and less than 100, that would still be something useful, interesting, right? And so much of what we do every single time that we are measuring things and we're estimating things, there's always error in there. And the thing to do is don't worry about it. Like, don't try to make it so that there's no error, because you literally can't. But be aware of, and maybe you note in your journal, the sources of error in your process. And hopefully what you can do, the best we can do in most cases, is get an upper bound and a lower bound. You can say, well, I know it's more than this and it's less than this. Or there's a pretty good chance that it's more than this and less than this, and this is what we call a confidence interval. We'll get to that later on. But the whole field of statistics is all about it's about that. So you cannot avoid error. You shouldn't try. If you want to reduce the error, you can do that by measuring things more precisely and having more precise methods. But you're never going to get rid of it entirely. So embrace it and acknowledge it, and be aware of what the sources of error are in your process. So
there's the idea of error, which is the mistakes we've made, and those are part of just doing this. It's okay. And then there's also variation, which means that the things which we may be measuring have, you know, some are bigger, some are smaller, which I just want to make sure I share my all-time favorite little. There is, whoops, hold on a second, get that video back. There we go. There is my smoothie. Up, one more time. There's a smoothie off on the side. The stem leaf plot is an incredibly useful thing that all of us nature journalists should have at our fingertips. And the way that it works is, let's say you are measuring the height of a plant, and let's say it is 15 centimeters. You could write down that it is 15 centimeters, all right? If you measure two of them and the next one is 22 centimeters, you could go 15 and 22, but then you start to get this big pile of numbers and it becomes a lot less useful. So a great way to handle this is what's called a stem leaf plot. And the way that you set it up is that the tens are over on this side. That's our stem. And then the leaves are out on this side. What did I say? That was 22. The 22 is there. If my next one is 31, I'm going to put the 1 there. If my next one is 24, I'm going to put that there. If the next one is 17, I'm going to put that there. If the next one is 9, I'm going to put that there. If the next one is 24, again, I'm going to put that there. And you see what I'm doing is I'm building up this diagram . And it records my data But if I take this and turn it this way, it is also shows you the shape of my data. So this data has a central tendency about here, and that, roughly most of it is here. I can get a sense of the spread and the central tendency of this data without needing to draw to calculate a mean and a standard deviation. So that's a really great way to record those numbers that takes into account the variation. Of course, as you're measuring these, if you're measuring kind of sloppy, then there will be error. And really this one that you put in as 32 was actually 31. So that's where error would be if these numbers are wrong. But here, this does allow me to get the variation. And I find that really, really, really useful. And I use this all the time in my nature journal. Just even if you're going to have 4 or 5 measurements, just do 53, 57, 41. Even if you don't have a large data set, just having a little mini stem leaf plot is much more useful than a big pile of numbers, unless the sequence of the numbers was important. For instance, I could do this to record dives of birds. I don't want to go down that rabbit hole there now. But so yeah, this is useful. And one other thing that I just wanted to show people is somebody mentioned making tallies a little bit earlier. And since I've got this whiteboard out here, you can make tallies like this. And then you get a whole bunch of these things. A better way of making tallies is the dot line method. And the dot line method works like this. 1 is a dot, 2 is a dot, 3 is a dot, 4 is a dot. They make a box. 5 is a line, 6, 7, 8, 9, 10. Every 10 is going to be a box with an X through it. And so if then I see another bird, oops, not yet. I see another bird, and then down the trail I see another bird, and then I see 22 more birds. Right. So it's very useful way of it's like tallies but better. And this was a system developed by foresters that I think that's pretty cool.
Can I mention something on in relation to your stem and leaf plot? Well, I guess in terms of all these things, is useful for a certain kind of thing. So tallies are useful if you are counting numbers of things, right? Here's a bird, here's another bird, another bird. Or in my case, a few weeks ago, here's a crested dandelion, here's another crested dandelion, here's another crested dandelion. Where does the stem and leaf plot come in? Is when you are sampling something. Now, I'm not necessarily saying you random sample or any of that, but you are looking at lots of individuals and you're measuring or counting the same thing on each one. So in your case, maybe you're measuring the height of each of these plants. So you can measure one plant. In fact, a lot of times if I'm looking at a particular plant, maybe I'll write the height down. If I'm measuring one plant, I'll just write the height as the height of the plant, right? If I'm going to measure 10 plants and compare how they are, that's when you might use a stem and leaf plot, because you're taking, we said, a data set. You've got multiple values where you've taken the same measurement from multiple individuals. And that can be something you've counted. That can be, how many seeds does this one have? How many flower heads does these one have? Or it could be a measurement that you measure, or an angle. It could be anything like that. And I will also note, if the thing that you're measuring, if the numbers you're getting aren't quite as precise, like you're doing this for 2-digit numbers. And the same thing would work if you had, numbers that were, say, 1.5 centimeters, 2.2 centimeters, that kind of thing. If you've got a couple of digits or even 3 digits, then a stem and leaf plot's great. if the things that you're measuring are not as precise as that, and you only have 1 digit worth of information, you can do kind of the equivalent thing with a dot plot. So say you're measuring something, and okay, so this plant has got can you see this? Has got 8 flower heads. Okay, I'm going to put a dot there for 8. Next plant had 7 flower heads. Next plant also had 8 flower heads. Next plant had, let's put 7 there, 9, 10. Next plant had 10 flower heads. Right? The next one had 9 flower heads. The next one had 8 flower heads. See how you're getting the same kind of thing, and you're getting, again, you can see the shape of the data. And when we say shape, what this and the standard leaf plot are both telling us is how many examples have what values. So, so the central tendency means, okay, so most of those flowers have about 8 flower heads. But, there's some that have a lot more. Maybe there's some that have 11, over here, right? And 12, and just a few of them have slightly fewer. That's interesting. I've learned something about the distribution of the flower heads on these kinds of plants, right? And same thing. Standard leaf plot is really, it's making that same kind of shape, and it's telling you how many examples, how many individuals are there that have a value that's somewhere in one range or another, right? So, in both cases, what you're displaying there is a data set where you've taken the same measurement on many individuals. And sometimes you're taking different kinds of measurements, you're going to display them in different ways. So that's the point I want to make.
Yvea, what are your thoughts?
I wanted to share another example of a stem and leaf plot, and this one combined with what is it called, context. So for example, the other day I was out pulling out mustard, and one of the things about mustard to do the restoration work is that you want to pull out the entire thing, because otherwise it will resprout from tap roots. And some of the times my peers in the field will just simply cut it back. And I was curious to know exactly what kind of resources we're leaving behind. So I did a stem and leaf plot on the taproot lengths so that I could see how deep they went. To add some context, I put stars next to some of them because some of the taproots had broken off partway. So that's a way that you can account for error in your thing too, is to mark down where things are inaccurate, or where you couldn't get an accurate measurement. So that way, that's a way of incorporating.
At least that much.
Yep. So, so this is sort of an example. Or if we're talking about biometrics, then I didn't have a tall enough ruler, but I wanted to measure about how tall most of these mustards were. And so I wrote down where they'd gone in terms of my own body, in terms of the biometrics. And then I estimated about what percent of them went up to my shoulder versus went up to my waist. So then there's a few more examples of that, or of how math can look in a nature journal. Another thing is that Marley Pfeiffer talks about using drawings as questions. So I wanted to show a quick example of that, because you can do the same thing with math. So for example, a while ago when we were talking about the moon and the earth and obliquities, then you can put an angle sign in here, but then put a question mark because you don't know exactly. Or you can leave these things as questions where you write down what you do know and what you don't know necessarily. Or here's one more example on the subject of something that doesn't have numbers, but is more math than numbers, on the subject of topology. Not knowing exactly why it is that the seeds aren't making that spiral that we're so used to on a strawberry. So then you draw what you think might be happening with the planes. And sometimes you might be drawing a math concept or shape to ask these questions. So another thing to think about might be encouraging your students to use their things as their drawings as questions with math and things like that. Yeah, that was mostly it. Or then writing down questions about why something didn't work. So for example, when we're measuring the color of the night sky, and we think about cyanometers as sort of bringing in both art and math, then you might be questioning, how can we accurately measure or see the color of the evening sky when you can't even see the palette or like the cyanometer that you're working with, because the light is weird? Does that affect how you see that? So then you ask a question and you leave that there. Or maybe you've noticed that the compass has a different reading than another tool because you're testing a different tool against that. So then you maybe you write that down with a question mark on it. Yeah, so just ideas about using your drawings as questions. I wanted to mention that as well.
I like that. Yeah, showing the uncertainty that we have, you know, is so useful in a diagram. You can diagram everything that you understand about something, and then you look down and you see where the gaps are. If you didn't diagram that, in your head, you'd think like, oh yeah, I totally get this. And then you start really kind of mapping that out and you kind of like, I kind of get this. And then here are the holes. Here are the holes. Maybe I can ask somebody, maybe that's an observation that I make on a different day. Or maybe it's something that nobody knows. Those are all really useful strategies. Want to say one other thing about someone mentioning graphs is sort of visualizing things. I just wanted to say something a little bit about graphs. Try not to get this into my beverage again. That Billy Joe mentioned, you know, sort of creating a bar graph of different things. You get the same effect of a bar graph by doing a stem leaf plot. So those two are very, very closely tied together. Another thing that is, I think, useful to think about is the idea of a scatter plot. And a scatter plot is where you are looking at, let's say, the height of something and the age of something. So two different things, and you want to see how they connect with each other, right? So for the stem leaf plot, it was all about the height of a plant. But let's say you wanted to have the height of a plant and connect that to the age of the plant. So you've got a way of, you know, measuring the rings or something. If the plant, and what you do is you would say, here's the height and here's the age. And if they get taller as they get older, you would expect things to have a pattern like that. Or if they kind of get taller at a slower rate, they would do something like that. Or if it's at a faster rate, they would do something like that. They also could, in their youth, grow and then flatten out. So the pattern that is made between these two variables is an interesting thing, and useful to get. So for instance, I've this is a dry erase pen that doesn't really want to erase. So one, I was looking at kind of growth rates on poppies, and so I had one poppy, and I would measure the difference between these nodes over time. I then could, on that same chart, I could do a different poppy and see how it compared, or another poppy in another place. So what I could actually do is get multiple, and then you'd want to use different kinds of lines for each of those. You know, the patterns, that the arcs that are made by those individuals tell different stories. So there I could have height and age compared across 3 different poppies. I also could look across a large meadow of things and say, is there a relationship between these? Let's say I'm not following one, but I can get information on the height and the age of all these different things. If the height is related to age, I'm going to expect to kind of get a cloud of dots that is going to kind of go up at an angle like that. That's sort of what I would expect if there is a positive relationship between height and age. It also could be that the older they are, then the shorter they get, right? They get, if you're talking about, say, not something that's growing, but maybe something that's wearing down, the older ones are going to be shorter. So the pattern that is made by these dots, whether it is generally what you're then, and then if I were looking at it and there was no relationship between these, then I would just sort of have a random cloud. And then you're not there's no real direction to that. So when you create a little graph like this, a useful thing to think about are two things. One is it a line up, is it a line down, or is it a cloud? And then the second is how much sort of signal to noise is there? How is it a tight little cloud like that? Or is it kind of loose cloud? The pattern that is made by these tells you something about the phenomenon that you're looking at. And it also can point out to you interesting cases. So let's say there was something like this, that. What's going on with this one? Right? What's up with you? Right? Wow, that's interesting, because sometimes the exceptions tell us something really interesting about the general pattern. Everybody's doing this. Over here, we didn't get the memo. So what's happening with that one? Oh, it's in really nutrient impoverished soil. It's trying to grow out of that crack in the rock. Oh, interesting. Or maybe it isn't, and there's something else going on that you just haven't thought of yet. So with these sorts of graphs where you're looking at two variables, you can have a lot of fun. First, just you collect your data, and then you say to yourself, is there a pattern here? And it's useful to say, can you kind of is it generally kind of going up like this or down? And the things that are more kind of the less steep it is, the more fuzzy it is, the less of a relationship you're going to be seeing. So would love to hear your thoughts, Susan, as a mathematician, about this kind of geeking out and these sorts of graphs in our journals.
Sure. Well, Yvea, you had your hand up. So do you have a comment on that as well? Or?
Yeah, a quick comment that I had is what Jack was saying about the story within the data inspires me to also highlight a way that the numbers and the words can play in your journal, is that you can start by making an observation about the data, but then that's a really good time to put in a why web, where you can think about why something might be that way. So that way you're leaving yourself really open to a lot of possibilities. Just to make sure that you're not getting too stuck on the first explanation that comes. So it can be fun, maybe having your graph with your data, and then after that having a why web about just to really expand on that. So I wanted to highlight that. And go ahead, Susan.
Okay. Well, I was just going to, yeah, that's great. Yeah, I was going to comment in regards to the question of the scatter plot. This whole question of how close are all those dots to some hypothetical line that you could draw, or how far apart and scattered are they? Has a name, and that name is correlation. So the correlation is high if they are all, even if the line is fairly shallow, if they're all really perfectly fitting or very close to the line, you have a high correlation. If they're fitting a line that's wait, this is going down, you have a negative correlation. If they're all just kind of scattered and not really fitting a line at all, your correlation is close to 0. But we do have to be careful, because oftentimes we think, oh, okay, if there's a line, that means, for example, in your example with age, let's say that your flowers are tending to be taller than ones that are older, right? And we might assume that therefore that as they get older, they grow taller, that age causes their height to be higher. And I mean, that's probably reasonable in this case, but we have to be careful, because let's say, for example, that we looked at some data on, just as an example, we looked at some data on in my city, the number of swimming accidents on any given day versus the number of ice cream sales. And I can draw a scatter plot. So some days there's very few swimming accidents, and there's a lot, and they've sold lots of ice cream. And some days they've had more swimming accidents. They've also sold lots of ice cream. I think in general you're going to get this like sort of positively sloped line. So the question is, does ice cream cause people to swim badly? Or does bad swimming cause people to want ice cream?
Yeah.
And the answer is probably neither of those things, right? Oh, okay. It's probably that when it's hotter, people want to buy ice cream, and they also go swimming more. Right? So you have what's called a confounding variable there. I mean, so we have to be careful. Correlation does not imply causation. Just because there's a relationship between these two things that you're studying doesn't mean that one of them is causing the other. It could be that there's something else that causes both of them. Or it could be that there's a coincidence. It could be also that you just don't have enough data to actually see what the real pattern is. So again,
that's right. For any correlation, there are 4 possibilities. You've got A and B, and there seems to be a relationship between them. Notice that I said seems to be. So one possibility is that A drives B. The other is B drives A. The other is both A and B are driven by another variable, which you haven't identified yet, but they're not affecting each other. They're both driven by something else. And the other is that it's just chance. So these are the data sets you're looking at here are actual real data sets that per capita consumption of mozzarella cheese really does correlate very nicely with civil engineering doctorates awarded over time.
So if you go back to that, in the year 2000, there was not a whole lot of mozzarella cheese eaten, and also there weren't that many civil engineering degrees awarded. Over in 2009, it turns out both of those were higher. And also note, these are like 2 time series plots. They're not showing you the scatter plot there, but you could turn this into a scatter plot by, making these both, making the cheese versus number of engineering degrees, different variables on there.
That's right. So if you want to play around with that, there's a website called Spurious Correlations, and you can play with different variables and see how they connect with each other. That's right. So I love how you're pointing out that just because we see that these things seem to be in a pattern, that doesn't mean that there necessarily is a pattern or that one is driving the other. And the one final thing to think about this is that anytime you are testing a lot of different variables, by chance, some of those are going to come up with a positive correlation. So if you're just kind of searching like I wonder if there's a fit with this, 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 and this and this and this and this and this and this from your data set, you keep doing that enough, eventually, even if these things aren't driving each other, just by chance, two of them are going to happen to align. And so if you go kind of hunting around in a data set to try to find relationships, then once you do find a relationship, what you do is you just, or a correlation, what you do is you then say like, oh, that's interesting. You know, I didn't expect that. It wasn't what I kind of came in here to find, but then when I started just monkeying around with this data set, I found this little correlation. Then what you have to do is, with a completely new, different data set, not reusing that same set of numbers, go take a look at those two variables and see with a fresh data set, if it's a real phenomenon, they'll align again, right? But if that just came up by chance, then it's not going to by chance also just do the same thing in this next data set. So anytime you do find a pattern and you weren't looking for it, sort of suspect to yourself that this could be due just to me kind of monkeying around with a data set until I find two things that do match.
And then go look and try and disprove that pattern by testing that same thing more and see if you can
yeah. So not test. I wouldn't say testing it more with that data set. It's not that you need more in that.
No,
you put that entire data set aside
yes.
over to here, and then just you create and you just go out and do new measurements. Yeah. Are there any other numerical delights that you folks wanted to mention before we open this up to the room?
Well, I've got an example of something completely different, if you're interested. Just as an example, here's a fun thing you can do that being creative that led me down some interesting rabbit holes, but we'll not go too far. So we've been talking a lot about measuring sort of one-dimensional things, and you can measure the length of something. Even an angle is really a one-dimensional measurement. What if you want to take a two-dimensional measurement? What if you want to find the area of something? So I've been playing around with this because I started looking at some leaves in my neighborhood and thinking, there are just some well, it shrunk a little, but I mean, this thing was as big as my head, you know? And then here we've got my little leaf, it's not. So I thought, let me actually estimate the area of some of these leaves. So I thought this would be a fun example to show. Just as an example, like there's so much more you can do. Like there's no end to the math you can do. So this is here's a method here. What I did was I took each of these interesting leaves that I had, traced them. So I got as accurate a size of leaf as I could possibly trace. And then overlaid that with a 1 centimeter grid. So each of these lines is 1 centimeter apart, top and bottom. If you want to estimate the area, if you've got a thing that's a rectangle, you can just count. You can just find the length and the width, and you can multiply them together, and that will tell you your area exactly. This is not a rectangle; it's curved. Lots of curves, right? This one even and funky, right? So what do you do if you want to find the area? Well, here's a thing you can do. What I did was I counted how many entire squares were completely within the leaf. And I ended up with whatever number that was. I can't figure it. Was that 45? And I also counted how many squares are overlapping the leaf, but not entirely. And there's a temptation when you've got one that's like just barely like over here, you know, there's it over here to not count it. No, you're going to have some squares that are overlapping just a little and some squares that are overlapping it most of the way. You just got to count them and accept that you're going to have some error, right? But then we basically sort of work on the assumption that overall that those squares that overlap the leaf a little, about half their total area is within the leaf, and that's an assumption you make. And you can do that. You can basically say, oh, let's say how many full squares. Each square is a square centimeter plus half the number of partial squares. and that gives you an estimate of the area of your leaf or feather or anything else you might draw. You could do this with a map. If you had a reasonably accurate map that had proportions and a scale, you could do the same thing, but you'd have to, scale things appropriately. You could do this for all kinds of things. You could also say, if you want to put some error bars, you could say, well, I know that the area is more than 45 and less than the sum of these two, which I can't tell you because I can't read it right now. You can see, right? So you could, if you wanted to get a less precise but more accurate assessment, you could say, well, it's between this number and the sum of these two numbers. That'd tell you, right? You could do the same thing with this one here. So when I end up with the area for milkweed, I got this for this leaf, I got 64.5. And if you wanted, you could do this on multiple leaves on the same plant, make yourself a little stem and leaf plot of the areas of things instead of the lengths of things. You could do this for this. Something interesting happened with this leaf. Notice that because it's so loby, so deeply cut, I ended up with about the same number of full squares, but a lot more partial squares because the edge of the leaf is so crinkly. What that means is I actually got kind of a worse estimate. So this is kind of the middle of my estimate, but actually what I should say is it's between 44 and whatever the sum of that is, 44 plus 77, more than 100. Doing the calculations in my head, I'm not going to do right now, right? But here's something you can do. And then here I did this with Norway maple, that giant one. Counting the squares took a long time. So it's kind of one of these things, how much time do you want to spend on it? I ended up with more full squares and more partial squares. Got an estimate of that, and that was at 233 square centimeters. Did the same thing with this willow, but I realized, oh, that willow is so thin, it's like I'm not even getting any full squares in that. What if I wanted to measure this more precisely? What could I do? I could slice it up into tinier squares. So instead of going for 1 centimeter squares, I did it for half centimeter squares. Did the same process, and down here I figured out how many full and partial squares I had for that willow leaf. But because the squares I was using were smaller, the number of squares I end up with isn't going to tell me the area of the willow leaf. I'm going to have to divide that by something to get the actual area. So the question is, if the lines that I made are now a half a centimeter apart instead of a centimeter apart, what's the area of each of the little squares? And it turns out it's a quarter of a centimeter, a quarter of a square centimeter. So I figured out how many squares I had, and then I divided that by 4, and that gave me my approximate area. Probably, which would be better to write this approximate area as a range of values and say that it's between the number of full squares and the number of full and partial squares, rather than just having a precise number, because then I'm not really showing the error in there. So this is something you can do with all kinds of things to my area, but how can we take it a step further? Because the actual reason that I wanted to do this was to look at some caterpillars. It always comes back down to bugs, right? So this is actually what I was doing this, and this is sort of like, this is just what I really want to show here is not like, oh, look at this cool thing I did, but really here's how you can take all the tools and tricks you can think of, just add them to your bag of tricks, and be creative and figure out what to pull out, depending on the thing you're interested in investigating. And that might lead you to further things. The question was, I found this cluster of caterpillars. These are gregarious caterpillars. They all stick together. And they were eating this leaf. So I thought, how fast are they eating that leaf? Well, it took me a lot of work, and I learned a lot about what doesn't work in the process, but I basically tried to trace out that leaf. This was a leaf I used for reference. I scaled it up by 2, traced out in blue approximately the leaf. I took some measurements because I'm not going to touch these caterpillars because they're spiny and they sting, but traced it out. And then over time, over the course of about half-hour apart, I looked at how much of the leaf had they eaten, and I continued to try and trace out best I could, and then work out using that same method what was the area of leaf remaining. And then here's what I got. At some point, they just seemed to all kind of stop eating. So I left and took a hike. And when I got back, they'd eaten a ton more. So there we go. And then from that, I could also figure out, how much did they eat each time. Notice, by the way, I did make a bar chart for this. for a couple of reasons. One was to prove a point, which is that the way that you display your data is kind of up to you. There are conventions of how you display your data, but they're there for your purpose. And if you have a certain purpose in mind, then you can do whatever you want to. So here I made this, and I wouldn't call it a scatter plot. I would call it a time series plot here, because I'm looking at what was the remaining leaf over time. But then when I wanted to know how much leaf had they eaten over each span of time, I felt that, so the area of each of these boxes ends up corresponding to the area of leaf that they'd eaten. And in fact, sort of the part that's blue that isn't orange is the amount that they ate during this roughly half-hour time span. And then the next portion is how much they ate during the next time span. This one was over a longer time span, but the area is still, corresponds to that. So I was really using this tool to try and investigate this further phenomenon of how fast do these caterpillars eat this leaf. And in the process, just really, I can highly recommend sitting there for a couple hours just watching caterpillars. It's very, very pleasant, and leaves all kinds of questions. I tried to replicate the experiment on a later date, a spot when there are more caterpillars, and it turns out, well, they sat there for about an hour and a half and didn't do anything. And then they did do something so fast, they whooshed onto a new leaf so fast, I didn't even have a chance to draw the leaf or anything. I just had to give a quick estimate of like, this is how big the leaves are. Let's just sort of give a rough idea, a rough guess as to how much area they are and how much of it they'd eaten over that time. So, it turns out that despite your best efforts to be prepared and ready to do some things with numbers, sometimes nature will still surprise you and act faster than you can come up with. So my point with that really is to just give an example of playing with these tools and thinking about how you can investigate whatever phenomenon you happen to be interested in. And it's not about, you should make a scatter plot because of this. It's about, this is a thing I'm interested in. How can I then record that information in a way that's useful and tells me something about it?
I think this example is so instructive. It's so instructive. And also we see how those numbers kind of helped you kind of go down another rabbit hole. That's really cool. Thank you for sharing that. Are there other folks who had some thoughts about these numbers that you wanted to share with us? Give folks a moment. All right. And on not seeing any, Yvea, are there any last thoughts that you have about numbers and strategies with us?
My suggestion is to play with them a lot. And if you find yourself having a preferred nature journaling language, your nature journaling love language, whether that then try to see how they can kind of play with each other. If your love language is art, then see how you can use art to play with the numbers or to include the numbers. Anything from proportion to comparison to visualization of the data and whatnot. If it's with words, then think about how you can add numbers to your words or question the numbers and use the words to explain your thought process behind the numbers. Just find ways of playing with it until it becomes familiar to you. The only other last thing, because I think I forgot to mention this earlier, was that you can also use numbers in maps. Maps are a great way to use numbers, because maps will give you a context for how numbers are. This was just a small example of, I was trying to measure the beach during the king tides. And so this was when the king tides were in, and there was an earlier page where the king tides were out. So this is when the king tides were in. And so I measured how long the beach was. Unfortunately, my huge tape did not have the metric system, so I was a little disappointed. But I could measure how long it was. I could measure relatively where different parts of the beach were. So where the the sea rack came up to where the soil, where the sand began to get wet, the approximate way I was facing when the water was coming in. And then a few days earlier, I had done one as well when the tide was out just a couple days earlier. And so the difference between 100 feet and 510 feet to the water's edge was kind of interesting. One thing I wish I'd done was to add more about where the sea rack was over here so that I could have compared the two. But I just wanted to mention that one as well, using numbers in maps. And so, yeah, just remember to play with it, remember to have fun. Numbers can have a language of uncertainty too. You don't have to, numbers don't have to be the precise thing or the or the hard facts that we sometimes associate with them. Numbers are another way of playing and exploring. And so play with them like you're a kid who just discovered a brand new toy. And speaking of kiddos, I see that Angel and Jack are raising their hand. May I invite them in? Here, let's invite them in. I'm gonna add a spot. Oh, there we go.
Hello. Hey.
Hi.
So I'll show you how I have some numbers in my journal. I was doing this honeysuckle I found growing in our forsythia, and this is an enlarged picture. So I kind of like lined the honeysuckle up, and it was too tall, and so I put 2.5 times 2.5, so that's enlarged about 2.5, and then measurements here. This is 1 out of 1, so that's actual size. Same with this one, and then measurements, how big they are.
Nice. That's a beautiful way of showing scale, Jack.
And then right here I have the X for block X for 10. All the birds I see at the theater and not at the theater, and some mammals too.
Nice. See, this is what we want to get our students doing. I want to get your journal into the hands of other kids, to sort of see what you can do by getting your thoughts on paper. Really, really nice work.
And then I have in my metadata here, it was 80 degrees that day, and then the date. I always do the date, and then if I know the temperature, I put in the temperature.
Which of those different languages, words, pictures, or numbers, do you think comes sort of to you the most easily?
I don't know. Probably pictures, because I really like drawing, and I think it's really fun to draw, and words and numbers. I mean, I like them all.
That's great. Yeah, the more that you kind of cross-train and are ambidextrous, or with these different skills, that's really powerful. That's really powerful that you can kind of fluidly move from one to another.
Yeah, like some days I just write. Like I have some this journal, all I did was wrote what birds I saw that day, what temperature was, things that were going on. Like one day we saw a snake, so I wrote about that. And then sometimes I just like all the birds I saw and tally and do all that. That's just numbers and stuff. And then maybe I do lots of pictures, like maybe just work on, like here, I'm just going through seeingbirds.com and just doing stuff with some bobcats and a peregrine falcon and crocodile and little woodland. And that's it.
Jack, this is where we want to kind of move people's, what you're doing, this is exactly where we want to be. Really like the way you're using those numbers to visualize and to think about the phenomena that you're finding. That's great. Thank you so much. Yvea, is there something else that you wanted to say before?
I didn't, but I think Susan did. I saw Susan raising her hand.
We're going to bounce over to Susan. Hey there.
I just wanted to say to Jack, young Jack. I think that is so great. But one thing I noticed, and I think I've noticed in a lot of the pages that you've shared, is like it seems like you're just kind of building a habit of putting in measurements, putting in numbers. Make that a habit. Just make that just a part of the thing that you do. You're looking at something, you count it. You're looking at a thing, measure how big it is. Build that habit. And then I think, some folks in the chat have been commenting on how their students get scared when it seems like we're going to talk about numbers and math and things. And the more that you just do that just becomes a thing that you do, I think the less scary it seems. And even Jack, when you're not like making charts and graphs and things, sometimes you're just measuring a thing just to see how big it is, right? Then the next time you have a question where you think that maybe like making some kind of a chart would be a useful way to display that, you'll be halfway there already. And I think that just building that habit of being comfortable with that kind of thing is so useful and so great, just because then you will you'll feel more comfortable with adding new ways to incorporate these numbers, incorporate these tools into your journal and into your thinking. And like I think I don't know about you guys, that the most fun thing for me about all this is when I think of new questions, especially when the new questions then create new questions. And the best thing I've found about putting more numbers into my journal is when it makes me think of new questions. I don't know if you found that, but yeah. So that's the most fun. So I think really awesome work.
Yeah, Jack, thank you so much. Susan, thank you also for all of your thoughts and ideas today. It's been really fun to pick your brain. And your most recent rabbit hole with the areas of leaves munched by those hungry caterpillars. What a great rabbit hole. And in the process of doing that, you had to figure out how, well, there's a phenomena. How do I measure that? How can I extract some numbers from that? You came up with a really useful system that also gets us to think about some a lot of the issues that come up when we do play with numbers.
Well, and then one thing about that is it worked okay. It didn't work great. I didn't get a whole lot of data out of it. It was fun to do, and I learned a lot doing that. And I think that's really the perspective I would urge everybody to have is, like drawing things is hard, and we still muddle through and we try and figure out how to draw new things. Working with numbers in new ways is hard, and we still muddle through. It doesn't always work the first time, and we try again, and we learn as we go. And I think all of this is all connected.
Yeah, I love it. So I've got a few closing thoughts for folks. I'm going to bounce over to. I'm first going to share a screen with you. And so on my store, I've got a number of free resources. This Naturalist Tools journal insert is a really useful page that you can print out and put into your journal. And it's got the Beaufort wind scale, degrees of arc. It's got a protractor, measurement things for helping you estimate numbers, helping you estimate percent cover. And that's free. It comes in English and French, and it also comes in two sizes, a smaller size that fits a standard composition book and a larger size that fits an 8.5 by 11 sketchbook. What I recommend doing is, just so that they glue into a page a little bit easier, you just trim around that little edge there with a pair of scissors so that the page ends up being just a little bit smaller than the page you're gluing it into. And that's what that little kind of dashed line with the scissors on it is for. Other quantification resources. Let's see, there's our goniometer. So these are ruler stickers, are free downloads that you can print out on Avery labels. Same with these percent cover stickers. that gives you an idea of what sort of the area covered by something is. These will print out onto Avery labels, and they come in, these things will come in different sizes. So here's a 7-inch version and a 9.5 inch version, depending on the size of the labels that you use. One thing that I recommend not doing with these is to print them out and then make a reduction of them, reduce them so that they fit in your journal more easily, because then the ruler will be the wrong size. Lastly, on this, the book, How to Teach Nature Journaling, which is a free download from my website. There is a whole chapter in that on nature journaling activities that involve using words. And so, I'm sorry, involve using numbers. Those are also useful to check out. My final thing that I wanted to share, all that good smoothie gone to waste, is this is my my nature journal that I produce. So you can there's drawing, sketching, journaling pages, and in the back there's a bunch of resource pages on all sorts of things, including words, pictures, and numbers, and some strategies and ways of documenting and recording numbers. There also is a version of this, ways of measuring height, place to put in biometrics, protractors, rulers, percent, cover, estimating numbers, Beaufort wind scale, and degrees of arc. So those are very much like that journal insert that I had in the as a free download. No, you're not doing it wrong, but adding more numbers and playing more freely with numbers in your nature journal will open up windows and ideas and doors. If you get yourself comfortable with how to use different tools, you'll find yourself out there like, oh, I could figure, oh, I know what I could do. So I want to encourage people just to play with those and see what happens. It's a lot of fun, and also helps our students be able to see the relevance of numbers. My final thought is just on that point, that if mathematics is taught as just word problems and calculation problems, very often it's hard to really kind of get those to apply to the world around us. What we saw Susan do, which I think is really interesting, is she had a problem, and then she kind of went about like, how would I go about quantifying that? How would I go about exploring that? Let's come up with a system, and figuring that out is really useful, is really fun. And the more we do that, the more it helps us see that the numbers are really relevant to the world that we live in. I want to thank Yvea Moore and Billy Joe Reed for their continuing support on our Nature Journal Educators forums as co-hosts. I would also like to thank our special guest, Susan Beckhardt, today for her work and insight as our team topologist. We are really grateful to you. Thank you all for being here, and we look forward to playing with you again soon. Take care, everybody.